We're in chapter 2, lesson 1, and today we're going to learn about energy converters. We are in activity 1, reading all about energy converters. We made the claim that something went wrong with the electrical system in Ergstown that caused the blackout. What was the evidence that something went wrong with the electrical system in Ergstown? Do you remember? What evidence do we have to support that claim? So what we know is that all the lights went out at night. First they were on, and then all of the lights went off. They stopped working. We know the lights didn't break because they went right back on sometime later on that night. But to better understand what happened with the electrical system during the blackout, we need to investigate the electrical devices or the tools that are part of the electrical system. Here is our chapter 2 question. What makes the devices in Ergstown output energy or fail to output energy? We're going to put this question on our word wall that we have here. So if you have yours, you can stop the video right now and then copy chapter 2 question under the unit question. We've discovered that electrical devices have inputs and outputs. They have electrical energy as an input energy form, and they have other forms of energy as output energy forms. Output energy forms, we said, include light, thermal, motion, and sound energy. But I wonder why that is. Why do electrical devices have different output energy forms, even though they all use electrical energy from the electrical system? I wonder why that is. Today, we're going to investigate another question. How do devices have so many different output energy forms when they're plugged into the same electrical system? This is the question we're going to be investigating for the next 2 lessons. As systems engineers trying to help Ergstown solve their blackout problem, this is something we have to understand. In order to answer this question, we should first understand what it is that electrical devices do, what their function is in the electrical system. We're going to go back and use our reference book. It's all about energy. But where should we look to see if the book contains any information about electrical devices? What feature can help us figure out my question? Where should we look in the book? Yeah, you're right. It's a table of contents. We can use a reference book to find out what the function of electrical devices are. Remember, reference books are used to locate specific information about topics people wonder about. The table of contents on page 3 shows the main section in dark print. So what section do you think has information about electrical devices? Again, looking at my table of contents, where do you think we should go? Yep, you're right. If you look down at electrical devices, it starts on page 14. But the heading, the main section is called energy converters, and so that's where we're going to go. We're going to read page 14 together. You might have the book. If you do, great, open the book up and read with me. If you don't have the book, that's okay. We have it right here, and we're going to read this. So we're going to read page 14 together to find out more about how electrical devices are able to have many different output energy forms. Energy converters. An energy converter takes energy in one form and converts it to another form. For example, a car is an energy converter that converts chemical energy from gasoline to motion energy that makes it go. Electrical devices like radios and source converters like solar panels are 2 types of energy converters, but there are many other types. In fact, almost anything that does anything at all is converting energy in some way. Electrical devices. Electrical devices are energy converters that we use every day. All electrical devices run on electrical energy. they convert electrical energy into a different form of energy. That it could be light energy, motion energy, sound energy, or thermal energy. There are lots of different kinds of electrical devices. Here are a few examples. Radios and music players. A radio converts electrical energy into sound energy. The part of the radio that does this is called the speaker. Other devices with speakers and headphones, such as music players and telephones, also convert electrical energy into sound energy. We read that devices are energy converters. What are some forms of energy that they convert or change electrical energy into? Do you remember? Yep, there's 4 different types. They are light energy, motion energy, sound energy, and thermal energy. And they're all output energy forms. So what is the output energy form for a radio? So you can go ahead and look at my text again. What is the output energy form for a radio? You are correct. It's sound energy. Nice job. What is the input energy form for a radio? So what energy does it have to use in order to make sound energy? Yep, you're correct. Yes, great job. It is electrical energy. So on page 14, it says that a radio converts or it changes electrical energy into sound energy. So electrical energy is the input. That's what's going into the radio. And sound energy is the output. That's what's coming out of the radio. Nice job, engineers. You convert energy from one form to another all the time. What form of energy is evident? Is there evidence of when I swing my hands together? So I've got my hands here, I'm swinging them. What kind of energy am I using? You can do that with me. Yeah, you're right. It's motion energy, right? I am making my hands move. Now, what happens when I clap my hands? What form of energy is there evidence of? Ready? You can do that with me at home. Yep, it's sound energy. I am making a sound. The output, I'm going from motion to sound. That's what you're hearing. So rub your hands together really fast. What happens to your hands? Yeah, they get warm. So what kind of energy am I outputting right now? Yeah, we're converting motion energy to thermal energy, heat energy. I'm making my hands really hot. Devices convert energy too, just as you do. So the radio converts electrical energy to sound energy. The electric stove converts electrical energy to thermal energy. When I plug in my stove and I turn my stove on, my stove gets hot. But the input, what's going into it, is electrical. And again, what comes out of it is thermal. If you have your investigation notebook, you can please turn to page 22. If you don't have it, it's not a big deal. You can just pause this part of the video and try to make a graph, just like I have here. The columns in your graph are device, function, input energy form, and output energy form. So here are the directions. Read the electrical devices section, and it's all about energy. Use information from the book to complete the table below. Record each electrical device you read about in the first column. Next to each device, record its function in the second column, its input energy form, like how does it work, in the third column, and its output energy form in the fourth column. Completing this table is going to help you think about the function of electrical devices and how they work. So here's how you could complete one row of the table with the information that we read about radios. So the device we read about was a radio. The function of a radio is to play music. The input, like what kind of energy does it need in order to work? I need to plug it in. So it's getting electrical energy is the input. The output, what I'm hearing from it is sound and sometimes thermal. Like, have y'all ever had your iPod and you're playing music on it a lot and you touch it? Sometimes it gets really hot. So the output could be sound or thermal. If you have your book, you can go ahead and read page 15 and 16. But if you don't have it, not a big deal. We're going to read this together right now. Electric lamps. An electric lamp converts electrical energy into light energy. Sometimes when energy is converted from one form to another, a little bit of it gets converted to a form that you didn't want. Some kinds of electric lights get hot. That is because they also convert electrical energy into thermal energy, which is a waste of energy when you just want your lamp to provide light. Other kinds of electric lights, such as LED lights, are more efficient. They convert most of the electrical energy they use into light energy, and they do not get hot. A light like this one converts most of the electrical energy it uses into thermal energy, which is less efficient. A light like this one converts most of the electrical energy it uses into light energy, which is more efficient. Electric stoves. An electric stove converts electrical energy into thermal energy. We use the thermal energy for cooking food. Some other devices that convert electrical energy into thermal energy are heating pads, toasters, and electric heaters. Electric motors. An electric motor converts electrical energy into motion energy. Many devices, including clocks, toys, and even some cars, have electric motors. Electric fans. A fan has an electric motor, but it also has spinning blades that transfer energy to the air. The fan converts electrical energy to motion energy of air. If you have your investigation notebooks, I'm going to ask you to complete the table on page 22. If you don't have it, it's not a big deal. You can just make this device right here. You need to go through, you can go back on the other part of the video and stop it. And every single device that we saw, the stove, the fan, all of those need to go in the devices column. Tell me what the function of a light bulb is. What is it supposed to do? Yeah, it's supposed to light up, right? And so then you need to tell me what the input energy form is. What kind of energy does it use in order to work? And then what's the output? What is it giving out? So again, the light bulb, you have to plug it in. So it's using electrical energy. But the output, what it's giving us is light. And sometimes they give off heat, right? If you touch a light bulb when it's on, you can burn yourself because it gets hot. So right here is where you're going to complete this table, and I will see you in the next activity. Welcome back. We're in Energy Conversions, Chapter 2, Lesson 1. We're in Activity 2. You're with Miss Sandoval, and we're learning energy and electrical systems today. So in Chapter 1, you either watched or you built a simple electrical machine, right? A system being built. So which part, and all of these parts here to the left, which part converts light energy from the sun to electric energy? Yep, it's a solar panel. Nice job. What were the parts of this simple electrical system? So it's the solar panel, the motor, the fan, and don't forget the sun. Okay, so what was the energy source for our simple electrical system? Yep, you're correct, it's the sun. Which part converts electrical energy to motion energy? Right, it's the motor. The motor converts electrical energy to motion energy. Which part were we able to observe or see moving? Yep, it was the fan. Nice job. We can use a sim to create something similar to the simple electrical system that you built. We're going to select the sun as an energy source and then drag and drop a solar panel. motor, and flywheel into the system. Since the sim does not include a fan, a device called a flywheel can represent the blades of the fan because the flywheel blades move and so did our fan. When we built our simple electrical systems, we used a motor with fan blades attached to it. So in the sim, the motor and the flywheel together represent the whole fan. You can use a slider, you saw there, to select the amount of sunlight that enters the system. This slider lets you choose the amount of energy that will be transferred into the system. We are going to drag the slider to 100%. Shout it out or tell anyone near you what you predict is going to happen when I press the run button. What do you think is going to happen with our simple electrical system? So let's see what happens when we run the system.
Let's see what happens when we run the system. We're going to wait for all of the energy to be transferred into the system. We'll know that happens when the number above the sun hits 100. We'll observe what happens when the system continues to run for a few seconds. Now that our system has run, let's analyze our system. Here we see the energy transferred in, the energy in the system, and the energy transferred out. With the slider, we can drag it to any point during our system run. Let's drag the slider back to the point where all the energy was transferred in. Then, we will watch what happens to each graph as we play the run again. Watch the graphs. As the energy in system decreases, the energy transferred out increases.
Which form of energy is getting transferred out of the system? So if you're looking at my analysis right here, on the very right, you're going to see the energy transferred out. So what form is being transferred out? Yeah, it's thermal. Nice job. Add the energy in system to the energy transferred out. So add this 78 and 22. How does that number compare to the energy transferred in? You're right, it's the same. 78 plus 22 equals 100. So the energy transferred in is 100. So I want to show you the orange, red, and blue keys right here. So they represent the three forms of energy. Light is going to be orange, thermal is going to be red, and sound is going to be blue. So again, the red bar on the graph indicates how much thermal energy has transferred out. What form of energy is leaving the system? Do you know? Yeah, it's thermal. Nice job. Look at these little squiggly lines. Can you see those? They happen so fast. Those are red. That indicates that it's thermal that's leaving the system. Next, you will use the sim to create a system with light as the output energy and a system with sound as the output energy. So if you have access to the sim, you can go ahead and stop the video and do this part right now. If you don't have access to the sim, that's okay, because in the very next activity, we're going to do this together. If you have your investigation notebooks, please turn to page 23. If you don't have it again, it's not a big deal. You can just take out a blank piece of paper or whatever notebook you're using for science, and we're going to record our observations. So we're going to go over the directions together. Build and run a system in the sim with light as an output energy form. Think of a name for your system. Record it in the first column below. In the same row, record the system's parts, an electrical device in the system, and the output energy form or forms, because it could have more than one, of that device. Build and run a system in the sim with sound as an output energy form. Repeat steps 2 and 3 to complete the bottom row of the table. So again, 2 systems, light as an output and sound as an output. We're going to do an example together. So we just built a system in my sim. So what do you think we can call that system? Yeah, let's call it the solar electric flywheel system. Okay, so that's the name of the system, the solar electric flywheel system. And you can stop the video and you can write that in your table. I'm going to write it in mine right now. Solar electric flywheel. What are the parts of the system that you see right there? You are correct. The sun, the solar panel, the motor, and the flywheel. Nice job. What is the electrical device in the system? Do you know? Yep, it's the motor. Yes, nice job. It's the motor. So we're going to go ahead and put motor, an electrical device. And what is the output energy form of the motor? And remember, there can be more than one. Nice job. Motion energy and thermal energy. In this system, the motor converts or changes the electrical energy into motion energy and thermal energy. If you have access to the sim, I'm going to tell you one more time how to get into it. You're going to click on your student apps in your bookmarks, scroll down to the unit we're in, energy convergence, and you're going to click on the orange number 1 in the box. If you don't have access to the sim, that's okay. We're going to go ahead and do this activity together in the very next video. Don't forget, you need to create your systems in the sim and record your notes. Make sure that, again, 2 systems, light as an energy form and sound or as an output, and then sound as an output energy form. I will see you in the next activity. Back to Science with Ms. Sandoval. We're in Energy Conversions, Chapter 2, Lesson 1. In this lesson, we are doing a sim. We are going to use a sim to create a system with light as an output energy and sound as an output energy form. Don't forget, you need to have either your investigations notebook, page 23, or a blank piece of paper, or as investigations, like whatever notebook you want to write, because we need to go ahead and write the system that we built, the name of it, the parts that are in the system, the electrical device in each system, and the output energy of the system. So here we go. So we're going to create light as an output energy form. So I'm going to use the sun. And then I'm going to put the solar panel, and let's go through our devices. Let's see, I need to have light as in, let's go with the LED. So I'm going to hit the run button and make it run. Okay, so let's go back. Do you see how that just says 50%? I want to make it 100%. I want as much energy transferred into my system. So let's hit run again. And then remember to we need to press analyze to figure out what form or forms of energy were transferred out of my system. Okay, so here we go. So it's 100%. I'm going to hit analyze. So let's talk about our system. You can name this whatever you want. You can name it the solar electric light system. And then what are the parts of the system? Right, the sun, the solar panel, and the LED light. Nice job. And which device in this system is the electrical device? Right, it would be the light bulb. Nice job. So here we go. Now let's look at the energy transferred in. It's 100%. The total energy in system is 0. So let's look at the energy transferred out, because we need to know what the output energy is. So this says light is 75 and thermal is 25. So 75 plus 25 is 100, which equals a light transferred in. So we have both light energy and thermal energy that are energy output forms in this system. Okay, here we go. So let's go ahead. So that one was the light as an output energy. Now we need to do one that has sound. Now, we don't have a buzzer as a device, as a tool in this system, right? Let's go look through the ball catcher. Nope. No, but we do have the music player. So let's try that one. And then I'm going to hit run. So look at my music device. And in our previous activity, I told you that there were 3 colors, and those 3 colors meant corresponded to an energy output form. So we just saw red and blue. Do you remember what those were? Here, I'm going to push analyze, and I want you to tell me what you think the output energy forms are. They gave you a huge clue when we had pushed the run button. Let's see if you're correct. I'm going to hit analyze. So the energy transferred in was 100%. The energy transferred out. So if you were watching my music player, it was blue and red. And so we said red means thermal, right? Because sometimes our devices get hot. And then we said blue was sound. So there's 2 energy outputs. It's thermal and sound. Nice job. I'll see you in the next activity. Welcome to 4th grade science. We're in energy conversions, chapter 2, lesson 1. We're in activity 2, and we're going to be doing a simulation reflection. So if you have not done the sim that was required of you, I'm going to ask you to stop and then go back to the previous activity where it says sim in it, because this isn't going to make sense to you if you didn't do it. So here are some questions. In the sim, they're asking you, what forms of energy did you observe as outputs of your electrical systems? You had 2 systems that you had to make. One of them you had to build and run and analyze a system in the sim with light as an output energy form. And then your second one was you had to build, run, and analyze a system in the sim with sound as an output energy form. So you have those 2 that should be in your table. So what forms of energy did you observe as outputs of both systems? Okay, so in the first one you had light as an output energy, and the 2 output forms should have been light and thermal. And then in your sound as an output energy form, what output energy forms did you have in that one? Yeah, you're right. You had sound and thermal. So if you notice, you had thermal in both of those electrical systems. Sometimes, whenever energy is converted or changed from one form to another, sometimes thermal energy is produced, like whether or not that's what you want to produce, right? So again, if you, in the light as an output energy, if you touch a light bulb, when it's on for a while, it's going to be really hot. And so that's why you can't touch it, right? It's creating light and heat. When you use your phone for a long time or use your iPod or an iPad or a tablet for a long time, if you touch it, it's really hot. So that's why sometimes thermal is another form of energy that is output from your other devices. Great job today. I'll see you in our next activity. Welcome to science. We are in energy conversions, grade 4, chapter 2, lesson 1. We are now on activity 3, and we're going to reflect on our learning. We are working on this unit question, how does the electrical system work? We're learning all we can about the parts of the electrical system so that we can try to figure out an answer to this question. We're going to review what we already know about the electrical system. Here's our diagram that we've had, and as we learn about the parts, we're going to go ahead and fill this chart out. So we know that each part has a function. Parts of the electrical system include a power plant, wires, and electrical devices. So think back to the sim that we just did, and the reference book that we read in the past lesson, and the notebook pages that you did in your investigation notebooks were page 22 and 23. I want you to write what you have learned about what electrical devices are and what they do. So we know that they take in electrical energy. We know that the output energy could be different forms. We know that there are different kinds of energy like motion, sound, thermal, and light. And so I want you to go ahead and stop the video right now, and write what you have learned. So I'm going to do the first one for you. So we know that a fan takes the input is electrical energy. The output, what it does, is motion energy, right? Like the fan rotates and it moves and it sends out forced air. So go ahead and stop this part of the video, and I want you to tell me what you've learned about the toaster, the radio, and the lamp. We have a new vocabulary word. It's convert. It means to change from one form to another. The radio converts or changes electrical energy into sound energy. The toaster converts or changes electrical energy into motion and thermal energy. Can you use the word convert and write about what one of these devices does? For example, I have already done the first one for you. I'm going to do it again, okay? The fan converts electrical energy into motion energy. So I want you to stop at this point in the video, and I want you to write the word convert, and then talk about the toaster and the radio and the lamp. We have another vocabulary word. It's converter. Something that changes one form of energy to another. And I'm going to go ahead and I put the two words converter and convert on my my word wall. And if you want to stop the video, and you can go ahead and do that too. So all the electrical devices that we have looked at convert, or they change electrical energy into other forms of energy. That's why we call them converters. We have talked about this diagram before. So what do you think the function of the electrical system is? What do you think the function of this whole system that you see right here? What's its function? Yep, you're right. So it's to provide energy forms for people to use. So whatever electrical device is in there, like the whole purpose is to give us energy form. The whole purpose of a radio is to give me sound energy, right? So the electrical system provides electrical energy to make our devices work, and our devices change the electrical energy into different forms of energy. Here we go. The orange part, I want you to fill in your diagram. This is the part where you're going to stop the video, and we're going to fill this in. So the part we talked about was the converter. The function of the converter is to convert electrical energy to other forms of energy. Again, electrical devices can be called converters because their function is to convert or change electrical to another form. And then their converters could be fan, toaster, radio, and lamp. The function of the electrical system is to provide energy forms for us to use. And then 4 of those energy forms that we've talked about before, do you remember what they are? The 4 output energy forms? Yeah, next up, here we go. They are motion energy, sound energy, thermal energy, and light energy. So there they are on the bottom. You see the function. I want you to go in and put all of the information we have just learned about converters in your diagram. We're still going to fill out the other 3 parts, but right now we know all about converters. So please write this information in your diagram. Great job today, engineers. In the next lesson, we're going to continue gathering information that will help us understand the electrical system and how energy is converted into different forms. I'll see you in the next lesson.